How's it, guys? Got something interesting for you. So I came out, or the client complained about I hear the condenser running. Let's have a closer look. Cycle monitoring. Thank you guys for joining. If you're watching, I hope you guys will learn something from what I'm about to discover over here. So we're working on a Samsung DVMS. These are two standalone systems. Yeah, let me just show you guys we are working today. Beautiful. Anyway, to get back to this machine. Yeah. Change to previous contractor's name is on Scala. I'd like to take information. So, system runs, as you guys are probably able to tell, running right now. And compressor 2 is running at the moment. So we are going to wait, because what happens is we do have intermittent failure, and what we want to have a look at is these LEDs over here. That'll give us an indication of where our fault is. So the fault code that we're intermittently getting, I'm not sure if you guys are able to see the segment display over there. However, we're getting a E206 error code, which is communication failure with the main board to some of the slave boards. But then we also have a subcode, so it's very important when you're dealing with the E206. The unit will display and give you an extension of the error code. So it will be either C001, C002, C003, and so on. So we've got an E206 and we got a C002. Now let's just have a quick look. If we have a closer look, there we go. There we go. E206. You will see E206 is the primary code. Then there you have C001, and that refers to the hub PCB. If you have C002, that refers to the fan PC board communication error. So that's what we're having right now. But the thing to note, so our fan PC board is tucked away at the back there. Fans are running right now. But what we need to note is the fan gets its DC link supply from the inverter board. So we're just going to let the system run for a short while it's running right now. It just gave the error code, and as I'm in the entire process to take my GoPro, the camera died. So yeah, I thought I could record on here, but the battery died. The system came back on. So I'm going to let it run and see how long it takes before that fault code resurfaces, at which point we will then dive into it and try and diagnose this thing properly. So at the moment I've got both inverter compressor 1 and inverter compressor 2 running. So let's give it a little bit of time and see if we can simulate the required conditions to have our fault code resurface. Very interesting. So I haven't plugged in my converter yet, but I am making use of the BNet controller, which essentially provides all of the data as well, and this is for this particular system. have a look at, and now bear in mind, if you're looking at the pressures over here, I do have the front cover off, so that will definitely skew the pressures a little bit. But what I'm looking at is 45 and 44 IPM temps. That's fine. Compressor top's all good. Bottom. Low pressure is fine. I think I'll set up to run my. Yeah, I think I'll set up to run. To run the service check on it. Discharge. Auto fan, hot gas. I'm not seeing the suction 1 and 2 temps. So yeah, I think let's plug the service check in and utilize that. But at the moment it's running. So if we go to our trouble history, you guys can see the fault code that we've had was a E206, right, on this system. And you can see we have an outdoor main PBA communication error between master and slave, of course, between slave PC boards. And this has been resolved 17 times. So we've had this pop up intermittently several times. This very same system also gave us a E205, which we know is a phase. This one's saying now error code between auto inverter MICOM and auto fan motor MICOM. So anyway, that is definitely where we need to check in. However, if we're getting a fan motor MICOM issue and inverter, I'm pretty sure that it's going to be inverter 1, simply because there we go. So that's exactly what I wanted to see, and as you can see, during the course of operation we just lost the inverter PC1 completely. There's no LED indicator, so let's give it some time. The second one is still running. Let's give it some time. As you can see, we still have our LEDs on over here. And if I remove this plug, this board will switch off as well. There we go. Oh, wow. Did we catch something intermittently here? I touched this connector and the board switched off. Do we have a short somewhere? Could be the harness. We could probably do a continuity check on this harness. Could even be this one here as well. And that is the main communication between your fan board and your inverter board. So that was just something very interesting to note. So at the moment it's fine, but this one definitely gave us an issue as well. And this essentially just loops the comms, the 5-volt comms line back. This is the end of the communication chain on all our outdoor PC boards. So our terminals for comms to all of the indoor units, and that's a daisy chain, that's a loop. Comes to our main board over here. This is the brains of everything. We've got our hub board. From the hub board, we've got our, see if we can get in at the back. Then we have our EMI filter PC board 2 and 1, and below that we have our fan inverter board, and on top we've got our reactor coils and our inverter 1 and 2. But something is funky on this comms line. I think we need to investigate and see if we've got a damaged cable or if it's the board that's intermittently giving us issues. So I think I'm just gonna go ahead and remove this board. We can always do some bench testing to see whether or not this board is a problem, but yeah, and then we could probably just have a look at this cable as well, just to make sure that there's no kinks or any damage on this cable. We do have plenty of these harnesses, unfortunately not with me, but we do have these in stock, so we can supply a new. It's switched off again. So I don't want to say I'm leaning towards the harness, but something, yeah. Alright, I'm gonna go ahead and replace this board, or at least just unscrew everything over here. I need 2 hands to do that. Okay, let's remove, hopefully all these screws are gonna come out without an issue. Let's remove all these guys, very important guys. I've seen some crazy things when it comes to these screws that hold the inverter power module down onto the heatsink. I've seen guys use drywall screws. I've seen guys secure the entire board with double-sided tape, and I've also seen guys not use heat paste when they refit this board. Very important that you use heat paste. The system will protect itself and give a fault code, because yeah, that IPM can get upwards of 100 degrees Celsius, especially if you don't have any paste, or if what we refer to as a bad print. So you can see most of the paste is just all smudged and pushed to the sides, and there isn't really a lot of contact over here. That's heat transfer paste. Alright, let's go ahead and replace this guy. Alright, so we are going to take off this capacitor guard and fit this on the replacement board. But this board we are definitely going to test back at the office. Maybe I'll do a video of that. If anybody wants to see that, yeah, let me know in the comments down below. But we will do a test on the bench. We've got an inverter checker, so we're able to test this board and just do a inverter checker, and that way we essentially just checking that we're getting all our phases on the output side of our inverter power module. Alright, so what I'm going to do now is clean up this area. So there is a lot of paste on here, but yeah, it's also very hard and dried out, so that's not going to do a very good job in giving us the best thermal conductivity between the circuit board and the heatsink. As you can see, you've got the liquid line over here passing by, and that's where you get heat transfer. You've got a heat exchange over there, an expansion valve, and that primarily is to increase or improve subcooling. So this line is not cold coming to the PC board, but it's definitely cooler than the IPM. So yeah, temperature, as you guys know, cold attracts heat. So yeah, it will move from a high temperature to a low, so we're still able to absorb that heat from the circuit boards. One thing I didn't do is I didn't bring a rag, because this heat paste can get quite messy. So I'm just going to smudge this off on this board. And And yeah, you can see the paste is dried out. We're just going to try and clean this as best as possible. Get this area nice and cleaned up. And yeah, I'm not even using the blade now. Close that up. Fine, this is why you do. Okay, when you apply this paste, you don't have to go crazy. That is enough. And all I'm going to do is spread that out. And this is why the rag comes in handy, because now I need to clean my hands. But yeah, I'm just going to spread that out evenly. As evenly as I can. So guys, a little goes a long way. You don't need to coat this thing thick, so we just want a nice even distribution of this as best as we can. I mean, this is not precise. Hey. Okay, so the board is in place. I've taken the liberty to get this connector in first because it's all the way back there, but the important thing is, if you have a look, I'm not sure if the camera will pick that up, but there's plastic retainers over here. Ensure that your PC board is in place over there, otherwise once you put these 4 screws in, the board's not going to make good contact or even contact with the heat sink. And you also don't want to go crazy with torquing these down. So not the best tool to use it, but I'm not trigger happy, so I've been doing this for some time. So you just want to get it there, and we'll tighten it by hand. Just want to get it going. Okay. So yeah, as mentioned, you don't want to go crazy. There we go. Let's make sure this is yeah, nice and snug. Doesn't need to be crazy. That's it. Okay, now we're gonna go ahead and install all of our other connectors. Alright, this is our DC link. This is supplying this fan board with between 300 to about 700 volts DC, or 500 to about 700 volts DC. But I think it's more 300, to be very honest with you. 310 or something like that. There we go. As I mentioned, I'm not trigger happy, so I've been doing this for some time. So we're not going to over tighten these, we'll go over them by hand just to ensure that we have securely fastened all of them. It's not a lot of space. I think let's go ahead and use our magnet tool, which is something I would highly recommend you get, especially when you're working in confined spaces. So let's just go ahead and tighten this guy by hand, and hopefully we don't have any issues over here. Okay, let's just make sure we don't cross thread any of these. Alright. Okay. Go ahead and plug these guys in place. Inverter compressor 1, let's go. So yeah, quite a weird fault to intermittently, so yeah, some level of component failure. But yeah, that's the importance of having clean incoming supply voltage, and that's something that I missed showing, but it is quite important to always verify and establish that you are getting the correct voltage and all your phases are present in the event, or in the case of dealing with three-phase system like we are. Alright, so we'll put all those screws back. Our board is nice and secure. We're going to reconnect some of these plugs. So in order to get access to this, we have to disconnect the main incoming harness. Give you guys a visual on that. So our main incoming harness comes over here, and as you can see, that goes to our EMI filter PC board number 1 and number 2, and then we've got our inline fuses. So yeah, if you've got a direct short to ground or something happens, yeah. And I'm not too big of a fan of the new style, because these are the PCB mounted fuses, as you can see. So if you've got a blown fuse, you have to replace the entire board. The previous iteration was same fuse style, but it had these lug connectors over here. So these lug connectors here. So yeah, there was a spade section on the fuse, and yeah, you would screw them down. So it was a replaceable fuse. They're expensive, but at least you could replace the fuse. In this case, you have to replace the entire circuit board, which yeah, for me is not the best. Anyway, so now we will clip this guy in, and it's a little bit difficult to do it with one hand. We gotta lift and get it in there. So these two top clips, there we go, need to be in place, and then screw them down. Okay, then we can go ahead and insert these. And this is your neutral over here, which is essentially for your single phase controls. Okay. Alright, so make sure that we put everything back the way we found it. So I think I'll just put the camera down for a sec. And so we got power, and we've got all of our LEDs indicating, so we know the single phase portion of the board is switched on. So now what the unit's going to do is go through its initialization check, and you'll hear some of the relays now activate as well. There we go. Okay, so it's now going through the entire sequence, and all units are there, as well as our MCU units. Alright, so the last test would be to run a test mode. We're going to run it in test heat mode. So yeah, let's see. So I think the final test will be to check this board out at the office and just do a bench test on it. We could also measure the resistance and actually test your IPM module. So there is a way of doing that, but yeah, we're not going to do that right now. Time is of the essence. The facility houses and takes care of a lot of elderly people in frail care and memory care. So unfortunately the system was down since the weekend. It is Wednesday today. Tuesday was a public holiday. I was out on site on Monday, and everything functioned 100%, so I didn't feel that I needed to replace any of the components. However, on my way back to the office, Yeah, I got a call from the office just to state that the system is down again. So some of the residents have reported that the system is down again. So here we are. Let's see if that fixes our issue. And then we're also going to go ahead and get this model in serial so that we can do a warranty claim and get that warranty board installed back in here. This right now is essentially just to get them up and running, so that it is our winter season right now, so just so that the residents are not sitting without cooling and heating more specifically. Alright, I think I'm going to end it over here. Maybe I'll give a little short video as the unit starts up, but yeah, there's nothing more to it than that. So I hope you guys enjoyed this video. If you did, give it a thumbs up, and I'm going to try and get into posting a little bit more content, but it will be focused on the VRF systems or VRV systems. So yeah.